Okay, so today we're looking at the application of antiderivatives and some wording type problems. We're all of that. So reminding us of the power rule. When we integrate using the power rule of ax to the n with respect to x, we have to add 1 to the n, and we use the new value in the new exponent and in the denominator like this. And this is how we integrate using the power rule. Now, we cannot have n equal to -1. Why not? If n is equal to -1, it's going to be undefined, yes. If we're going to add 1 to it, we're going to get a 0. You're going to get a divide by 0 there in the bottom. You can actually integrate, so if n is equal to -1, that would be the function 1 over x. So it is actually possible to integrate this, and we don't do it on this course. It comes out as a logarithm, ln of x. We don't do this one because n is -1. And on this course for integration, we just use the power rule. So we can have 1 over the integral of 1 over x squared, for instance. We've done these ones, hopefully in your homework exercises. And you're going to get x to the -1 over -1, which, let's see, which is going to be -1 over x. Let's see. So make sure you're familiar with the power rule for integration. To have a go at that, have a go at integrating these 3 functions by hand. Pause the video now at home, if you're following at home. Okay, so there are a few ways we can do these ones. In A, we have the integral of x to the 5 over 4 with respect to x. So with a constant, we can rearrange this one to say this is the integral of 1 over 4 times x to the 5 with respect to x. We can move that quarter here if we want, sort of showing how you think. I would tend to do this in one step. And what I'm doing is I know that constant 4, it doesn't matter. We just leave it where it is. We can deal with it afterwards. All I integrate is the x to the 5. Now x to the 5 is going to become x to the 6 over 6. And then 6 times, let me write it like this, x to the 6 over 6. This is still times by a quarter. And that's where we get x to the 6 over 24. And we end by adding a plus c for an indefinite. So I would normally do this from here to here in one step. So x to the 5, I add 6, and then 6 times 4. One step. I'm showing too many steps, just so you can see how it's operating, where it's working. They aren't required. So with this one, it's a term-by-term integration. I'm going to do it in one step. So it's x to the 3 over 3. So it's going to be x to the 3 over 2 times 3, 6. The second one is going to be x squared over 2. I can't combine that 2 and that 3. It's not going to cancel. And then the last one is going to be minus x plus c. Our last one requires that we rearrange our function into index form. So that will be 4x to the minus 2 with respect to x. So we need to add 1 to -2. That is going to give us 4x to the -1. To the -1 over -1, which is going to be minus 4x to the -1, which is minus 4 over x plus c. Okay, this next routine, I'm going to run through question A. This next routine is the core routine for this topic today. There will be a question with this routine on. So basically what we're going to do is you're going to get given a derivative and a point on the original function, and you're going to try and find the original function. the antiderivative. You bring those back to the original function. But as we saw with each one of these, we end up with a plus c. So we've got to get rid of the plus c, and we use the point, put the point in, and then we can solve for that one. So let me do this first question. We have the curve f of x, which passes through a point. So this is a point on the original curve. We're given the gradient function, we're given the derivative here, and we have to find the original curve. So we are going to find f of x, which is the integral of f prime of x with respect to x. This from the fundamental theorem of calculus. So in order to do this, we put in our function, our derivative function, which is 2 plus x over 3. And we have to integrate this with respect to x. That is going to give us 2x plus x squared over 6 plus c. So first we need to find the indefinite integral, and then all we need to do, this is what the function is going to do, but we can then put it together with that point. So we know that the y value should be 3, so we're going to insert 1, 3. We know that the y value should be 3 when the x value is 1. So 2 times 1 plus 1 squared over 6 plus c. We can end solve if we want this, but look, we've got 3 minus 2, so that's 1. And then we're going to, 1 squared is just 1, so we're going to take 1/6 away from 1. So c is going to be 5 over 6. If you end solve it on your calculator, you'll get that. 3 minus 2 minus 1 over 6 is 6 over 6 minus 1 over 6, 5 over 6. So our final answer is we have to find the original function. And the original function now is going to be 2x plus x squared over 6 plus 5 over 6. This is the core routine for today's lesson. There's a similar question in B now. I'd like you to take a couple of minutes to have a look at that question in B. Pause the video. Try it. Okay, so we're doing the second one now, B. What we need to do for this one is we need to find the integral of 2x minus 4x squared with respect to x. Coming around, looking at your working, this bit went a lot better this time, so the integral of 2x is going to be x squared. The integral here is going to be minus 4x to the power of 3 over 3 plus c. That's our first part. Then we want to insert 3 comma negative 1. So coordinate into that, which is going to give us negative 1 is equal to 3 squared minus 4 bracket 3 cubed all over 3 plus c. And if we end solve this, we get c is equal to 26. So our final answer is we need to find y in terms of x. So y equals, where is it? It's up here. X squared minus 4x cubed over 3 plus 26. We can try it. Let's just check it with the end solve. So menu, algebra, end solve. Negative 1 equals 3 squared minus, put the quotient, 4 times 3 to the power of 3 over 3. I don't know what's going on over here. Plus c, comma, solve for c. Syntax error. What's going on with my calculator? I missed the 4. Well, the 4 isn't here. 26.
Oh, I didn't have a negative. I got a positive. My x was 3, my y was 1. Can you try as positive?
Well, taking away one. If you have one, then you're having two. All right, our last bit. So, what we're looking at is there are some, often the hardest part of this topic is questions that are quite wordy. And sometimes it's good to have a familiarity with how different properties relate through integration and differentiation. Usually, most of the questions, you can see clearly because they'll give the question like they did here, and they'll say, you know, the rate at which, they'll often say the rate at which whatever it is they're talking about is increasing. The rate at which what we're talking about is increasing is given by this function. So when they talk the rate at which something is changing or increasing, it's giving you a derivative. But many physical properties are connected through calculus, such as speed, distance, and time. If you differentiate displacement, we get velocity. You differentiate velocity, you get acceleration. And if you integrate in acceleration, you get velocity, and so on. The ones we often do on this course tend to be focused on economics. So ideas such as marginal cost and cost, or marginal revenue and revenue, marginal profit and profit are mixed on this one. So what I recommend you do, if you want to figure out what marginal cost things are, I have tagged on a video for you to watch for today's lesson. Put it here. I'm not going to show it now. I'm just going to finish off with our last question. But you can find in the Google Classroom a video explaining what marginal cost is, and it's the cost of producing one more unit, the rate at which the cost is increasing. So find the cost function C of x when the marginal cost m of x is 1 plus 2x, and the fixed cost is 40. So we need to know what these terms mean. Let me do this one for us then. So the cost function is the integral of the marginal cost function. So we need to integrate 1 plus 2x with respect to x. That's going to give us x plus x squared plus c. Now in this particular case, which one of those would represent the fixed? If this is the cost function, and x is the number of units we're making. The question is very unspecific. It doesn't say what we're making. But if the cost function is c of x, then x has to be how many units we're making. So the fixed cost is the only thing that doesn't vary. What would that be in this question? The plus c, the 40. And what did you say? $40. So the cost function is going to be x plus x squared plus 40. Fixed costs often represent maybe the hire of the location or the cost of buying the equipment, depending on what the actual situation is. All right. So we are finishing with integrate with Unit 8 for today. You need to work with exercise 13H and 13I before next class. Next class we will do a practice paper, a practice major for the summative assessment, which is coming in class after on Tuesday. Also on Tuesday.
It's on Monday.
Oh, so it's on Monday. It's on Monday.
So you can go back to the last slides.